Good morning. Today we will be identifying the layers of the Earth and explaining each layer's different characteristics. You should be on page 5 of your notebook. This is the right-hand side of your notebook. This is where you take your notes. Our Earth is broken into 4 main layers. On the left-hand side of your Cornell notes, your first topic to write down is Earth layers. Across from that, on the other side of the line, on the right side, you're going to give the examples of the 4 Earth layers. First, we have the crust. This is the topmost layer of the Earth. This is where we live. It is also the thinnest layer. Below the crust, we find the mantle. This is the thickest layer of the Earth. That's going to be really important because of something called convection currents that we'll discuss later. Below the mantle, you have the outer core. And the very center of the Earth is called the inner core. Your second topic, just write as you go deeper. And then on the right-hand side of the line, we're going to write 3 things that as you go deeper are going to increase. As you travel further down into the Earth, the pressure will increase. I like to think of this as if you've ever been swimming in a deep pool, if you dive down deep into the pool like in the picture, you start to feel pressure on your ears. Sometimes your ears will even pop. Sometimes it even hurts. It feels like something is squishing your face or your body. This is because there are a lot of molecules above your body that gravity is pulling down on. So the more substance that is above you that gravity can pull down on top of you, the higher the pressure will be. As you go further into the Earth, the temperature increases. It gets really, really hot. And finally, the density increases of the layers. What is density? This is a concept you probably haven't discussed in detail since 6th grade. Just a quick review. Density just means how tightly packed together the molecules in a substance are. So how close together are they in relationship to how much space, how much volume they take up? So looking at these 2 pictures of substances, which one would you think would be the most dense? A is the most dense because you can see the molecules are very close together, tightly packed in that space. So as you travel deep down into the Earth, all the way to the inner core, the molecules, due to the pressure, are going to be smushed closer and closer together, and they're going to have a higher density. So I keep saying, as you travel into the Earth, but the reality of the fact is, scientists can't actually travel past the crust. The deepest we're able to go with the machines that we have is 8 kilometers, which isn't very far. That's like driving from Hollygrove to school. So how do they actually know that these 4 layers exist? Third key point. We have 2 pieces of evidence over the years that we've accumulated to help us understand that these 4 layers exist. So on the left-hand side, you should have number 3, evidence, and here are your 2 examples to write on the right-hand side. The first is rock samples. When volcanic explosions happen, rocks from deep below the surface of the Earth come out onto the crust, and we can analyze them and see what they're made of to learn about the layers from where they came from below us. And seismic waves. These are waves of energy that are produced due to earthquakes deep within the Earth. And as the waves of energy travel through the layers, they change their pathways and patterns so we can determine the density of those layers. So, what is the history of this evidence? Let's learn a little bit about the scientists that actually discovered these 4 layers.
Seismological stations around the world had made recordings of the same. In 1906, British geologist Richard Oldham was analyzing seismograph readings caused by a large earthquake when he saw something odd. As the vibrations from the quake reverberated, they did not arrive at the center of the Earth as expected. It was as if they'd hit an obstacle. Oldham realized the obstacle must be the innermost part of the Earth, a dense mass hard enough to have deflected the seismic waves from going all the way through. Oldham had discovered the Earth's core. It was a landmark discovery because it set the stage for the work of another scientist who was about to help revolutionize our understanding of what was happening inside the Earth. With Oldham's discovery, many believed the picture of the Earth's core was complete. But in the early 1930s, Inge Lehmann wasn't so sure. Lehmann was a Danish seismologist who worked extensively in Denmark and Greenland, studying the velocity of seismic waves from earthquakes. In 1936, she was analyzing the seismic waves from an earthquake that had occurred several years earlier. Seismological stations around the world had made recordings of the same quake. By comparing their readings, Lehmann calculated that as the seismic waves had passed through the Earth's core, there was a change in their velocity, as if they had encountered another boundary of some kind. Then it occurred to her. Something was missing from the accepted structure of the Earth's interior. The Earth didn't just have one core, it had 2. The core that Lehmann had found was the Earth's inner core. Today, through precise seismic measurements, we know that it's made of solid iron. Solid because gravity at the center of the Earth creates a pressure 3 million times the pressure it exerts on the surface. The core that Richard Oldham had discovered turned out to be the Earth's outer core. It's made of liquid iron and other elements, a hot churning mass that generates electric currents, which in turn create the magnetic field that protects the Earth from dangerous cosmic radiation. Together, the 2 cores that Oldham and Lehmann discovered form a massive structure over 4,000 miles in diameter, slightly larger than the planet Mars. At the center of the core, the temperature can be as high as 13,000 degrees Fahrenheit, which is 2,000 degrees hotter than the surface of the sun.